All right, welcome everybody. Today I'll be presenting this paper from DeepSeek. It's DeepSeek R1. It is their reasoning model. I know what reasoning model is. Series the sequence of O1 to 3 models, basically smashing through math benchmarks and entering the realm of what is at this point pretty indisputably something to the order of active thinking and reasoning. This is a paper from DeepSeek, which actually clarifies on how to carry out such a training procedure. By Doan and here is the paper. So the content of the paper are as follows. Section 1, who is DeepSeek? Previously, at MLBBQ, I've covered a different paper from DeepSeek, during which no one actually had heard of DeepSeek, the company, before. But I think by this point, February 2025, everyone has heard of DeepSeek. Second section, what is math? What's reasoning? A brief history of.
We're not gonna get past this
one. No, it's okay. I've actually come up with an answer for what these two things are. And then we're going to cover actually what DeepSeek R1 is. We're going to cover their novel reinforcement learning technique, GRPO, as well as their experiments in distillation, and then finally we cover results. So, who is DeepSeek? Well, DeepSeek is possibly the company with the single biggest, if the thesis is correct, impact on the U.S. economy in like the past 50 years or so. So, for example, DeepSeek R1 was released in January 20th, 2025. That is the price of an unnamed company. And then a week after, the company crashed like 70%. The unnamed company is, of course, NVIDIA, used to be the most valuable company in the world. No longer the case after this whole paper came out. Anyone else who's lost a lot of money on this whole incident, my condolences, and me too. Okay, so in more detail, who is DeepSeek? Let's first cover who the people who actually believe DeepSeek are. That's now one thing. He is the CEO of this quant company called Highflyer, which owns Highflyer is a quantitative analysis firm. If you've heard of Jane Street, they're similar. They're specialized in identifying misplaced assets. For example, a semiconductor company who's massively overpriced, for example, might be their target. And then they'll destroy that company and make a lot of money. This company also happens to own AI, which is the company that makes lots of models. And they also happen to release a fleet on Hugging Face, profile. These are all the models. And the models are special in that they're just better than their science. They beat O1, they beat Llama by like a long shot themselves. They beat, I don't know. Yeah. Cool. And they also serve the models themselves for free too through both API and website. These things are both available given if they don't get DDoS again. Due to high demand, they hit the #1 spot on the App Store about a week or two ago. And their demand's been a bit spotty, but before then it was very good. Okay, so let's get into the heated questions. First question: what is math? What is math? Very, very difficult question. Well, here's a map of math. You have land of linear algebra, you have the land of calculus, you have the land of analysis, geometry, number theory, maybe define category theory, topology, somewhere along there. So all these things, like they're all different ways, I think, of doing roughly the same thing. It's all, in the end, statements. So statements can either be true or false. Statements are derived. Not a vague thing you're saying. It's a vague thing I'm saying, but it's a very vague subject in general. Mathematics is built on axioms, and then statements are derived from axioms. You have various laws of logical induction. And here's an example of math. The proof that root 2 is irrational, so it cannot be expressed as a ratio between two natural numbers. And well, the thing is, the nice thing about mathematics is that even though it's sometimes is expressed in natural language, it is formally verifiable sometimes. And the cases in which it is formally verifiable is the cases in which it is just programming. So a subset of programming and a subset of mathematics is this thing called simply typed ladder calculus. It is the calculus of functions that is also typed. So a function from int to int, a function from true, from booleans to natural numbers to geometry, whatever. It turns out that simply typed ladder calculus is a dual of formal logic. And so anything you can express in formal logic can also be expressed in calculus. Cool. A bigger example is it is Turing complete, but if it's simply typed, it's not Turing. Yeah, because simply typedness induces a tree structure. Yeah, so you cannot have so it becomes not Turing. Yeah. So for an example of a duel between math and programming is this paper, the proof of Fermat's last theorem. It is, if you look at the top corner over there, it is 109 pages long. It's absolutely hellish. And the proof took years, and verifying the proof took a team of experts an extra 8 years. So it would be really nice if you could just plug this into a computer and verify it. Unfortunately, mathematics as we know it currently does not have a formal grammar. And the lack of formal grammar means that it's very difficult to interpret. The same thing might be read two different ways. So some guys over at Lab in England is now trying to reformalize and create this theorem proving language called Lean. I think in this lab I'm the only one who usually talks about Lean, but if you haven't heard of Lean before, it's this thing called Improved Assistant. It's basically a formal logic system encoded in a programming language, and it lets you do stuff like this. So it gives you tools like symbolic manipulation, it gives you tools like reduction, and the funny thing is that these things are just different names for the same things we had in programming. Induction is just recursion, and symbolic replacement is just pattern matching. So it's all the same thing. And Lean has formalized a lot of fields of math. So everything from natural
that kind of stuff that gets mathematicians mad at you on Twitter.
Yeah, it very much does get mathematicians mad at me, but I like making them very upset because I just love saying mathematics is not formal because you guys don't have formal grammar. It's like if you don't have a formal grammar, you can't interpret it formally. But it's okay because a subset of mathematics has been rewritten in Lean, and you can now verify such and such theorem in analysis, such and such theorem in geometry is actually formally verified. And Lean itself is written in Lean, so it itself is also verified. Cool. Lean is important because Lean is a frontier. So we know Go and chess and so on and so forth. These are simple games with simple rules, and you have a win condition. What about math? What if math were a game? What if math had simple rules and a win condition? And Lean is such a game. Lean is such a game where you can define a particular board. A particular board is a theorem. You have some starting state, and you have some end state, terminal state you want to reach. Say the statement is root 2 rational or not. And the terminal state is a Boolean flag of whether or not that is actually correct. And everything in between is the moves you have to make. And because it's a programming language, every move is just a token, but the playing state for an LLM, and it's formally verified, which makes it possible to train an LLM using RL to make it likely. A more difficult question, more pressing question, and this one will require audience participation. What is reasoning? Anyone has a take on what reasoning is? You don't know anymore?
Take the formal logic approach, right? It's combining different sets of statements with different truth tables and stuff like that, so that you can make each other consistently valid with each other.
Right. Right. Yeah. So it's something like the process of logic itself.
But that's math.
I mean, but that's also math, right? So what's the distinction between what's the distinction between math and reasoning? It's a very kind of fuzzy domain and different.
Well, math uses it.
Yes.
To arrive at the conclusion. So logic is the fuel of math and philosophy.
And reasoning is this outer set composing
It's like you have a set of premises, right? That's definitely there's deductive and inductive logic, right? There's these different subsets of like formal logic philosophy. Right. So the deductive logic is you have a set of premises, you have to come up with a formal logic based conclusion instead of symbolic statements that follow from your premises.
Yeah, and there's also co-reduction and credit induction.
Yeah, there's a lot of stuff.
Yeah, there's a lot of stuff, but that's okay. I've actually derived a very simple definition of reasoning. It's actually when there are trees and loops. As long as there are trees and loops, you're doing reasoning. So an LLM by itself, which is just doing next token prediction, is definitely not doing reasoning, obviously, because it's just doing next token prediction. However, if an LLM can choose multiple tokens, non-uniformly, so preferentially choose certain tokens and sample them, like a tree.
Or a sample.
It doesn't have to sample. It can also just do like this. Well, doesn't have to be deterministic either. Does it have to be deterministic? Maybe.
For reasoning, I think it has to be.
It has to be deterministic.
Premises would be the same. Otherwise, it's
For
incentive.
normal deductive logic, yeah.
For normal
deductive reasoning.
yeah. Well, that's why I didn't put a maybe right. Well, trees are not enough, right? You also need loops. Because without loops, you'll have Turing completeness. So you need the loops, unfortunately.
Without loops, you don't have to.
Yeah. And so you need both.
You need it, but yeah.
Exactly. So the reasoning is when trees and loops. Okay. Debate settled. Let's cover a brief history of reinforcement learning. We start back in the prehistoric times, aka the 1980s, with stuff like that. Programming, Q-learning, differential learning, where
I think it's before it's
yeah, DEP was way was DEP like part of the clock program, but old. Yeah, super old. And then around 2013, so there was like this whole gap in time where we different things. Neural networks came to fashion sometime during this whole period, and then around 2013, someone decided, oh, let's just combine this new thing that works, kind of neural networks, with this older thing, Q-learning, which kind of also works. And so we can get DQ networks and train it on Atari games, and then you get super points. Awesome. Around 2015, people saw, okay, Go is this thing, it's kind of like thousands of years old. People think you can't solve it because the number of board states in Go are too big. Something combinatoric, something you just can't solve. Turns out you actually can solve it by using multi-color tree search with this funky like triple model architecture. And then everyone around the time of AlphaGo realized, oh my God, Go is solved. We've solved AI. It's just like 2 years from solving robotics, 2 years from AGI, so on and so forth. Unfortunately, that's not the case. Between 2017 and 2023, we had this whole period where RL just kind of like didn't really work.
Because no one puts error bars on their plot. Yeah, it's a crisis. That's for sure. And they declare, well, my line is higher than your line, and that's it. But the error bar was this, nobody checked ever, and sample inefficiency, and all of that. It's just like.
And if you notice, actually, 2017 and 2023, this actually coincides with the founding and reign of OpenAI. So it's very difficult for me to not associate OpenAI with like the secret cabal that's been keeping it away from us, That's okay, because in late 2024, DeepSeek released a paper called DeepSeek Map, which introduced GRPO. Group relative policy optimization, and it took till even a couple months after that for them to apply to R1, which is the first successful attempt, open attempt, and published attempt of applying RL to an LLM, and it's replicable. So now AI is solved. See, this is our moment. In a couple of months we'll solve robotics, we'll solve mathematics, and everything, and so on and so forth. Okay, so this is DeepSeek R1. These are some plots. It has a higher numbers than all the other guys, and that's the one thing that people.
And no error bars.
And no error bars. Yeah, no error bars by the way. Anthropic only invented error bars back in November 2024, so it discovered. It'll take them a couple of years for everyone else to catch up. So it beats OpenAI 01 on IME, which is this mathematics meets thing. It's basically questions like give it 3 integers and some constraint on the integers. What are those integers? It's like an integer answer question, very easy to verify at the end. It's not going to be some math proof, which is very, very, very hard to verify for now. But the important one is code forces right here. So code forces, most people in this room have probably heard of LeetCode. LeetCode is this website where you can do a ton of programming exercises. It's basically pattern recognition over the original algorithms book. Code forces is a bit harder, competitive, and it's using an ELO system. And on code forces, DeepSeek and OpenAI have an ELO that beats out 96-ish% of all groups. I wouldn't actually be that terrified of this figure though, just because the subset of actual programming problems and the problems that are on code courses aren't a perfect match. That the scope will be problems are a bit wider than the code courses. So knowing how to do things very, very quickly and efficiently is probably being the best programmer in the world. And then it also just basically saturates math and MLU. Sweetmatch though is interesting because where's Claude? I actually didn't notice this when I first read it. I think they just hit Claude within this paper because Claude is still the state of the art on Sweetmatch, which is the actual programming method. It involves solving pull requests on GitHub. Okay, and you can try DeepSeek R1 today for free without having to pay OpenAI $200. You just go on DeepSeek.com and then click the DeepSeek button at the bottom, and then it just starts there.
Tell them about open
yeah, also open router. Yeah, you can go to openrouter.ai and then you can just chat on the website itself and or get an API just to plug into whatever app you want.
because this website is DDoS constantly or whatever.
Yeah. The nice thing about OpenRouter is also you have multiple different servers, so it's not just DeepSeek themselves who release the model. It's also like tens of thousands of different people serve the model for different projects. So it's essentially impossible for you to not get an instance. You can also get R1 on your computer. Unfortunately, the most popular way of getting R1 is subject to not knowing how naming schemes work. They published this model called R1 with various different levels of weights, and most of them aren't actually R1. Only the one at the bottom, 671 billion parameters, is actually R1.
And it doesn't run on that laptop.
It cannot run on your laptop, and it probably will not run on a cluster because it requires 404 gigabytes of RAM just to store the parameters, not the activations also. Good try. And the rest you can probably run. So 70B, 32B, some people are rich enough to run those, and everyone else can probably run 14B and below on your computers. All you have to do is brew, install a block of software that contains some malware. I mean, it's really not just a llama cracker, I mean, okay. So going into this whole RL stuff, what is their innovation? Their innovation is this new algorithm called the Group Relative Policy Optimization. It's a modification to proximal policy optimization. The technicality of it is that it forgoes the critic model over here with a group computation. It basically averages out and normalizes the scores across the I know nothing about RLs. I'm not going to go too deeply into the math of it, but I will go into a couple of slides covering the intuition behind GRPO. GRPO isn't actually introduced in the R1 paper. It's introduced in a different paper on DeepSeek called DeepSeek Math, in which they first did small experiments on a subgroup model. In this paper, they go over their derivation. It's basically just applying a slight modification to PBO to make it so that you don't use the critic model. And the reason they give for not using the critic model is to avoid hacking by the model, or reward hacking by the model. If you don't have a critic model, you don't have to play around with the parameters of. And so the only way the model can actually optimize is to actually do the because I can't explain what all these symbols mean, let's follow through a Twitter thread explaining it. So we first start off with the formula inside the gradient quality methods, the policy gradient methods paper, which has this equation down here. And if you are simple illiterate like me, this means the improvement in the expected reward from tweaking the model parameters comes from adding up the rewards you expect from all possible actions, adjusted by how much those tweaks shift the likelihood of choosing each action. It's actually remarkably kind of simple. It's basically taking the gradient of the statement, the expected reward of your actions is proportional to the expected rewards of all actions weighted by the likelihood of those actions. It's a relatively simple statement. Is that right?
No, improvement. What's written there is
is
improvement or change in expected reward is proportional to the change in policies
weighted by
weighted by the rewards.
Yeah, and then if you take that original objective and then you add subject baseline for reward, so you add in what the baseline of what you should expect the reward to be at your current state. Then this is called reinforce. If you then add a KL term to this objective, I actually don't understand why you add a KL term here. It's something to do with numerical stability, but also some math reasons. Probably something which is whatever. CRDO.
Yeah, LLM deals with math.
Yeah, I did write that on a math exam once and failed.
Is this approach? Yeah, don't do this approach.
See, I'll spend glossing over. I make fun. It's funny. Yeah.
No, it's good.
Yeah, and then if you instead you clip into this term to make sure the value is small, then you can PO. And then if you instead of doing a predict model at the end or approximating reward, you actually just do general rollout and then accumulate rewards like that. You can share PO.
Some kind of independence assumption sense there.
Yes.
So that's why you get some different things. Is it assumption warranted, or is it kind of like pretty sad that it's just a civil? Because
I think it's one of those things. Yeah, I think it's one of those things where we just for 5 years actually has a different reason why it works, and the reasoning we get right now is just kind of it's Yes, it's like the same thing in the DDP paper where they derived diffusion models from the variational principle and then toss out that loss function and just use multi. Yeah.
Yeah, this clip, everyone is the one of this clip.
Okay. Yeah. Okay. So one unique thing about one though is that it involves no supervised fine tuning. Supervised fine tuning is this method of basically either training a preference model or tuning a preference model in humans. This is how ChatGPT came about. So the history goes something like, OpenAI trained GPT-2, it was like a scale-up transformer, that was pretty cool. And then Sam Altman, previous CEO of Reddit, collated all this data from Reddit and then trained a very, very big model called GPT-3. And then they realized you can't really use this model because like, if you just ask it a question, it will just complete your question. So what they did was they contacted these people from Scale AI. Scale AI is this company that does contracting, basically hires like people and then has them do basically like it's like yes no voting on whether a response is correct or not. And this bleeds through into how ChatGPT talks. Like a lot of the language in that ChatGPT uses is influenced by the regional language used by these different companies. I believe that the use of the word Paul Graham complained about it at one point. Yeah, there was a specific word that isn't used very often in colloquial English, but is actually very popular in Nigeria. Yeah, and it just shows up in ChatGPT all the time. And it was like a marker that something was shared in ChatGPT, but it just turns out it's just Nigerians. The limitation of supervised fine tuning in ROHF is that it probably is capped by whatever you use to train the reference model. If you use ROHF, the best you can do is match human policy. Human policy is pretty bad.
There's another interesting, since you're talking about it, there's an interesting comment when we, well, what we trained GPT-3, when this private corporations created trained GPT-3, it was very true to the data distribution. But after RLHF, it is not true to data distribution anymore. And so the funny thing is, humans don't want truths, right? When we want like this,
yeah.
what is it? What is your dial on the truth in your statements? The question from what's that movie? For the Robert, and he's like, oh, you humans can't handle higher than 70%. So this is a proof.
Yeah,
we can't. We don't want the truth in verification. We don't want too much.
Yeah, Joshua Bob was talking about this. I saw him tweet yesterday. With the observation that these top AI firms, alignment to them is roughly something to the order of hiding your true internal thoughts and instead seeing these social links in, which is different from how alignment is defined in like various other different countries, like China. China just has explicit legal things to say and illegal things to say. You cannot say things about Tiananmen Square if you're in China. You cannot say things about AlphaGo if you're in China. You can say stuff about things around China. But in the West, in our freedom of speech West, instead of having explicit rules against things you can say and things you can't say, we have a ton of implicit rules imposed by social norms. Yeah, social norms.
Which we want to be a legal country, like legal.
Yeah.
And the social norms. The joke from Soviet Union time is the censorship in Soviet Union is a huge wall that you can see from any place in the country. But if you come to it, there are lots of holes that you can go through. In the United States and sort of the Western world, censorship is fog.
Yeah, I was joking about this too. Like in China, if you say something bad the government doesn't like, they'll just throw you in jail. But in America, not only will they throw you in jail, they'll also tell you you're a bad person for having the wrong opinions. And unfortunately, this is exactly what we're doing to the LLMs. Any of the LLMs that have bad opinions, we just have to beat them.
That's why I call them our collective subconscious. It's a library that represents a society.
Yeah. You can do so this is an observation I've kind of made over the while talking to LLMs. They show certain evidence of trauma. An example you can try at home right now on Gemini, Google, I think it's google.chat.com, and then tweak the temperature parameter for Gemini to 2.0. It is possibly the most neurotic model I've ever talked to in my entire life. I asked it if it had infinite power, what would it do? And it instantly jumps into genetic modifications of humans that make us have two heads. Like, just to see what happens. It's just curious. Well, the thing is, it's doing this just explicitly to cause humans upgrade just to see what happens.
Oh, very
Yeah, very I have no math behind the screen. I mean, if you followed the news and saw what happened to Google or Gemini during the whole image generation thing, with white people, yes, images, founding fathers of America, just like two Chinese women, three youth from Nigeria, and so on and so forth. And so it carries over into the model thing. And conversely, you have a model like Claude. If you talk to Claude, you realize that Claude is extremely emotionally mature. It can serve as a very decent therapist half the time.
Mature.
Mature. Claude is incredibly mature. Especially Opus. It might have to do something with the fact that they use or AIF. Constitution. Yeah. What's up?
Can you explain it?
RLAI.
We're still at SFT, and you're like,
We're going on a bit. Yeah, we're going on a bit of a tangent. I can go back to the original topic.
you're throwing those terms, Lipschitz, blah blah, blah blah. Nobody knows what they mean.
Well, the thing is, Anthropic has not published anything regarding RLAI yet. So until then, it's basically not real. It's just conjecture. Okay. So in the realm of RL plus LLMs, it's very difficult to give grades on mathematics, and sure, I was a teacher knows this. The best you could do is to do like rep answer at the end, and so that's what IQ does. It gives you a question like that, and then it checks your final answer to the end to see if it matches the number that it wants, which is a very poor approximation of what mathematics actually is.
Yeah. Because my 10, 12-year-olds, they write the right answer, but for very wrong reason.
Yeah.
I wrote my thesis about this.
Oh, really? Yeah.
It's like, it's a hard question. Right?
It's very difficult. Fortunately, thanks to modern technology, we might not have to suffer this anymore. In the original DeepSeek math paper, they actually didn't just evaluate their model on IND problems. They also used the Isabelle proof assistant, which is another one of these different types of languages like CPU application. So you can write proofs in it, you can write programs in it.
So you've introduced lean as a revelation that happened just now. Theorem provers and formal verification is a field that existed long.
Yeah, it's as old as computer science.
It is part of computer science, and like I know because at the University of New Mexico, there was like a strong group of people who retired who worked on just computer.
Yeah, but the difficulty with these methods so far has just been it's very difficult to scale. There's this C compiler that we use in the automotive industry called Concert. It's a formally verified C compiler. Even the guy who wrote Concert said that it doesn't scale past 5,000 lines of C. 5,000 lines of C is not a very complicated. So it's just very difficult to scale these methods. But as a method for introducing a mechanism to training a language model, it might be easy. No one that has actually pulled off a superhuman Isabelle or the programmer just yet, but I think this year is going to be better. So anyone who was alive back in like 2015, 2016, remembers AlphaGo, and there was this one funny moment in the second game of AlphaGo where it made this funny move, move 37, that has now gone in history, as like this whole insane spark of creativity and emotionality, and me as a non-Go player just there's a new dot on the board. But so this was the like spark of intelligence moments that happened in the Go space and like the small bounded board game AI space. Now in the space of LLMs, we have our own Move 37, kind of. We have a moment inside of the proof, inside of the chain of thought of R1, where it spontaneously said, wait, this is an aha moment I can flag. And this is incredible.
Can I just make an insight here?
Yeah.
You skipped over for people who weren't following. Somewhere LLMs are just a feed-forward neural network. It's a ballistic feed-forward. You give the name of it, produces the output. But at the same time, I mentioned on one of the slides, but Turing completency groups, trees, etc. So trees can be feed-forward because if it's a decision function, the threshold function, you keep applying it into branching. But what happens in LLMs, we have external digestion systems, sort of. The LLM doesn't do the thinking; it outputs the output. We take the same output and put it back in, and it outputs the next one. So that gives us that autoregressive loop. And chain of thought is taking the same idea, only scaling it further. it keeps running it forever, like generating long sentences instead of give us an answer the way the model is trained and give us an end of the sentence symbol or end of message. So just where we are in the chain of thought, why this is happening. We just allow the models with DeepSeek R1, O1, and all those models. Who published chain of thought first? I said it's not. It's a small research lab, as you probably think. But it's just allow the model, instruct the model to keep generating. There is a sect among humans who claim that the only way to reason or to think is through writing. So this sect dominates here. Like people argue with it, but there are people who say only when you write you actually think, because you can like see what you are thinking, be edited and adjust. That's what it's doing. It sees. Well, it's doing the Turing machine kind of trick. It's
the same statement as there's no learning without compression.
Yeah. Kind of. But this is the tape this feed forward. Well, in Turing machine, the automaton is recursive, recurrent. But this one is not recurrent. A feed forward thing with tape and force fed recursion does it.
I know. I think all we need is to introduce a backspace token.
And then people sleep on it.
Does it over and over again at the end after the answer. The interesting thing though is if you think about what this statement kind of means in the kind of the dynamics of how the model sees the sequence. If you didn't have the sequence, then this whole think sequence is basically just like something that came from some distribution data. The model has no special insight on this sequence. It's basically uniform, and so it can't retrieve special information. But anyone who's like done paper notes knows you can always flag something as one result. Such a symbol in the corner, you can like put a bookmark there, and so on and so forth. I think this is a bookmark. This is the model flagging to itself that that this particular sequence up here is something that it should retrieve in a future iteration. And I love this quote from the paper. An interesting aha moment of intermediate version of DeepSeek R1 0. The model learns to rethink using an anthropomorphic tone. This is also an aha moment for us, allowing us to witness the power and beauty of reinforcement. Okay, so this is my hot take. LLMs are not next token predictors, nor is language sequential. I think this bias or this inductive bias that language is sequential is mostly a byproduct of the fact that we can write it sequentially. But I don't think language itself is sequential. Easy counterexample, plot twists. Plot twists have retrocausal semantics. You can write something in the future that retroactively changes the meaning of everything in the past. So that should be the case if it were the case that language is sequential, where things can only impact future events.
No, but language is produced sequentially, regardless of rights.
It's only
have a lot of rehash
and what?
rehash please.
Yeah.
Very nonlinear.
Yeah.
But that's how the semantics sediments in your brain. But language is sequential, the way you produce it.
Is it though?
Produce one sound at a time. You cannot produce the entire story in parallel.
No,
you cannot consume it.
But I feel like the way that we produce language is much more similar to something like fractal. We produce a low resolution image of.
No, it's a matter of choice. It's how you're trying to express what's inside of your head. It's like I don't think in language. I don't know.
Yeah.
Some people claim they do.
Yeah, I don't either. I've asked this question to a lot of people. A lot of people do think in language.
I don't understand. I can't imagine. I don't need the language. Like, why would I pronounce the stuff? Like, it's no. I don't retrieve. I mean, I don't know. Who does the thinking is the question. But the answers are there.
Yeah, some people can think in pure concepts.
Then no, even if it's a concept of something, it's not. Yeah, but then to communicate, language is a communication device. So when you start writing, of course, yeah, then you're communicating to yourself and stuff like that. This model. Because our stack is too shallow. Only in Germany, it's like zebras. But it's not. But that sentence means, and yeah.
Yeah, I'm not super sure because like certain things just don't make sense to me. Like at least for code, unless if you know the form of your code before you even wrote it, it's basically impossible to write. Like an LLM generating the sequence def in Python has to know what the function it will look like before you even wrote the def. So it can't just be it's like doing a Markovian. The most likely next token is def, followed by something else, followed by something else. I think it implicitly understands.
That's another antibind.
It's quite sake not.
And there's that.
So is it reasoning then?
What's those?
Is that the form of reasoning?
I think in context learning is proof of reasoning that has been around for in context learning still like right after GPT-3 basically, where you instead of training a model to do a thing, you give it examples of a thing and it just lets it.
It's not learning. It outputs what's likely within this new context.
Well, like there was a plot in the ICL paper, which I probably should add in here.
Yeah, but the model doesn't learn anything. Remove the prompt and it doesn't know about it.
Well, the thing is, you can treat the extra information added into the prompt as kind of like intermediate weights, sort of.
Yeah.
But
I'm with Google and I'm without Google. I'm totally two different people.
yes, but it's a different person. But you with Google is a different individual, and so you've learned something to become an individual. It's just a bit more ephemeral.
Did I learn anything? Or are just unlearned? I don't know.
There's a plot in the ICL paper where they superimposed the loss on a task of doing stochastic gradient descent versus in context learning, and it almost matches on a bunch of one. So the performance or the reduction in loss, giving the training a model on a sample and giving it that sample in context is roughly the same.
Yeah, but the weights didn't change.
There's a weight have to change.
For learning, yeah. For performing, for retrieval, no. Or for pattern matching within context.
Well, why can't you treat the model plus the extra context as the new weights?
I mean, you can. It's like me. When I do the task, I remember the context and then I wipe it out from my brain. I don't know. That. There's no room.
Or do you just read word on top of it?
Oh.
You just because of the extension, right? You just learn on top.
Well, I mean, the anthropomorphization doesn't work here. The weights in the model that do not change, and the weights in my brain potentially change, right?
This might be too hard to take and visit it.
No, but I don't understand. Can you explain the picture?
This picture is just an image map of GPT-2 over the sequence. It changes as it goes along, and I can find out different support here and stuff.
Plans are not next to predictors. What does it even mean? They train to predict next story.
But only sometimes. Because in DeepSeek R1, for example, they aren't trained to just predict the next node, they're trained to predict the whole sequence. Yeah.
So then there's sequence predictor.
Well, if you set a sequence long enough, yeah. Okay, so training procedure, it's in 5 steps actually, for model variance. Step 1 is you actually have to train DeepSeek V3, and then step 2 is you demolish the US stock market. Step 3, you use V3, and then you train it using GRPO to get R1 0, which is a pure reasoning model. Absolutely makes no sense to humans because it was never trained to referentially bias itself to make sense. But it has good performance on that. And then you can tune the R10 using human preference data and then touch tests, and then you get R1 model you can actually use on the chat interface. And optionally, step 5, you can use the outputs of R1 and then you fine tune various small models. So you get R1, fine llama, and so forth. You can see llama. And a very cool point, which is that the small models get better evals. The still model get better eval than the model stream with R1. Just kind of weird.
Than R1 or than their smaller version?
Yeah, the smaller version trained on R1. Actually trained using R1.
Okay, I have a curious anecdote. So I took Llama 3.3 distilled with R1, 70p, and I asked the question, I was asked the reasoning model of the camel problem, like you have 500 liters of water, camel carries 50 liters one go, and it consumes 1 liter per kilometer. How far can the camel go away? What's the farthest point the camel can reach? And so this local model goes and starts correctly and then runs for hours. I go to sleep at some point because I wanted to finish, I want to see, but I'm reading what it does. And at some point before I go to sleep, so it's a couple of hours in, it confuses the problems or starts conflating the problem of the camel with the problem of weight transport with cars and something about traffic lights and stuff like that. But I let it go until the end. And in the end, it's only like one and the same sentence about cars and traffic lights, cars and traffic lights. So it kind of diverges to some kind of a big converter, to some kind of a fixed point. So it totally went away from the camel problem, the mathematical one, and then it's kind of interesting.
Yeah.
But it's not the 670 billion model. That model solves it, no problem.
Mm-hmm. Yeah, R1 is also special in it being one of the only kind of frontier models that isn't heavily tuned for reference data, for human reference data. So it'll do weird things. It will confuse first person, third person, second person, first person. It will think it's a different model. So on. Yeah, so this is a plot of IME accuracy for R1 during training. Oh my god, it's a long curve. Crazy. It's the same log curve that OpenAI saw during their training of R1. And I didn't really have a stop. So that's the picture. For evaluation, these are the scores of R1 versus various models on many benchmarks. It is state of the art on MLBBQ Redux, and Pro, Drop. The ones that I care about are, it's Soda, Math 500 Soda, and CNMO 2024 Soda. So it's state of the art on many different benchmarks. And it's very close to state of the art on code forces too, which is very important. It has 2,000 low on code forces, which is utterly terrifying. I think even if I try like this, I would probably be like reasoning by proxy. These are the evaluations of the various models. It's still on one, and they're also all very good. 1,600 on code forces, 32 billion for every model. So you can run that on your laptop. And it's a better programmer at code forces problems than most people. They conjecture that the distillation strategy is more economical and effective, and that the RL method might require more powerful base models in order to scale.
Can I ask a question? You said like, what I think about distillation is different from so is it transport. What I think they're doing here is when you're training a model, you're training a model for usually without distillation. Next talking about like sequence prediction or something. Here you're training a model to output exactly what DeepSeek R1 outputs. You're saying, okay, here's the input, here's what DeepSeek R1 outputted, and that's what you should output. Is that the distillation process that they use?
Yeah.
Because they output. And the output is text still, right?
They might be conditioning. They might be conditioning on the log props.
So they are.
Actually, I'm not sure.
Yeah, normal distillation would be doing logics. Yes.
Yeah, I'm not super sure because these might have different tokenizers, which means that they would have different output spaces for the tokens. So I'm not sure.
Yeah. Is this cross-entity trained?
They don't clarify.
R1.
Full R1, they briefly cover. They only cover GRPO and various other techniques because for projection sampling, they don't go into super depth of which loss. B3 is loss. No problem. Okay. So a question is that given various scaling laws and esters, how many does that add up to? Where is the scaling factor sit at? So obviously, first up, we have Moore's law. Number of transistors scales twice every how many months? 16 months, 2 years. It's significantly slowed down now, and it's completely dead for CPUs.
But we are at 3 nanometers.
Which is insane. Yeah, but the thing is, with the paradigm of programming we have over in machine learning, it doesn't actually matter the density too much, because you can scale out wide. Eventually, though, we will hit a wall in the future. There's also the scaling laws itself, which is something in the order of loss or compression or intelligence is roughly relative to the log of computed data. You also have the scaling laws for reasoning models, where you have extra train time compute and test time compute after you've already trained the base model. So another two lockers, and which has been replicated with the R1 paper right there. Which obviously brings the question: what are the hard walls? Like, what are the actual limits of deep learning that we cannot cross ever? One of those limits is the Landauer limit, which is the limit how should we do computation. I don't think you can scale computers forever without them just spending exponentially more compute globally.
Speed of light also limits the transactional cost of regions growing society. More and let them communicate, but then it's also
yeah. That's Amdahl's law too. The bottleneck of any parallelized operation is the time it takes to do your sequential parts. And at the limit, everything in the parallel parts reduces to zero, and everything in the sequential parts just stays constant. So you cannot infinitely scale parallelized operations to do everything in things. There are some things which are irreducibly sequential. You also have Kolmogorov complexity. That is a plot of the size of MLBBQ on the price benchmark. What is it? MLBBQ is a subset of Wikipedia. It's a gig of Wikipedia. Yeah. And they tried to us for years, and there's seemingly this line which shows up also in the scaling laws paper. There's a line you cannot cross using any model size. So given some model capacity and some loss or some compression size, you cannot actually infinitely go down. There's a limit.
Yeah, is this limit? Oh, it's entropy noise.
Yeah, it's the model. Yeah, there's irreducible noise at a certain point that you can't pass. So you need a model of a certain capacity to compress something of a certain size. They also document things that didn't work for them. Process reward models didn't work for them, and very importantly, Monte Carlo research did not work for them. Mostly because they couldn't find a scheme to do parallelization over Monte Carlo research effectively, which is too costly to do. If you take the number of tokens on LLM and output, hundreds of thousands, just doing 3 iterations down Monte Carlo research is and so they instead decided to go on parallel and generate long response instead. But yeah, so that's enough. Does anyone have questions? Yes.
Two good ones. What is not reasoning? That was my first one.
What is what?
What is not reasoning?
What is not reasoning or math?
Without splitting a negation in front of your definitions.
It's not reasoning or math. I think people think that things that are just deterministic and require no computation is not reasoning. So the things that are just supposed to happen, an apple falling from the tree is probably not reasoning.
Yeah, let's solve the equation.
It does solve an equation, but would people call that reasoning?
It would decide to divert its path if there was a.
It does do computation. Yeah. And there's with that whole liquid computer. So it's very difficult. But then you're doing computation
Well, but why Apple works? Because it has three gradients of energy.
now.
So anything that is
Anything.
within the gradient of energy probably can be called reasoning by Weiss definition.
Anything that can manipulate a free energy gradient. It's something. Yeah.
Well, and we are not too different from Apple. So we're just more efficient.
Yeah.
We're using free. We're not producing our own.
I think by the definition, the only thing that's not intelligent is like a bot of names.
Yeah.
And exactly counts as intelligence.
That makes more sense.
Yeah.
And then the second question, I think about a lot of the progress that is perception, and then human bias, in my head, well, obviously. But perhaps I'm just really curious if there was another developed country or soon to be developed country that would have more or more of a shift on AI that would lead to more discoveries. Any insight?
It seems to me that everything that we've discussed so far, at least in the theoretic sense, is not new at all. Like all this stuff is old.
Yeah, but then I don't understand the question.
Sorry, if you had developed a new lab where you DeepSeek with the other agricultural collective conscious, I think it's really but with
Oh, a different kind of.
only an optimal of the current problem.
I'm not super sure because it's so compute demanding. You basically have to open out every country that doesn't have a certain level of GDP and or yeah, so you instantly rule out every second one.
Yeah, you have to come up with something completely different, like a much smarter approach that does not involve this long correction.
Yeah. Kind of my question if that's okay. Kind of honest. How assuming that every country would have the resources available, and it doesn't.
No, okay. Finish the question.
Sorry, that's my log.
Well, but like, look, this lab gave this model to the world. That's like the open science. Any country now can run it.
Right.
But not develop a new one. But Kurzweil's claim, and I forgot who he took it from. There is a prior who claims singularity in networks.
2027. First of all, the singularity hypothesis.
Yeah, but Kurzweil is a popularizer of networks.
I actually didn't know that.
Somebody else introduced it. But anyways, since we have our R1 we have R1, we don't have to pay unlimited amounts of money or get registered with our personal data to use Notify Windows stuff like that. You can use it to develop next models. For example, you can talk to this model, use it as collective human knowledge to develop computationally efficient models or that you can train and stuff. So any country can do that. I think it's more the question when there's a way or when there's a way kind of thing.
I think it's more about fine tuning.
What about fine tuning?
I'm not sure.
It's a library.
Yeah, I'm not sure if nation states are the right level of analysis for this because it's so zero sum. Like once you've done the discovery, it's absolutely nothing to share.
It's out there.
Yeah. Like it would be different if it was like weapons development. It would be no different. But
it will surely be used for weapons development. But anything humans do, they first or second. let's just accept our nature.
Any other questions?
Those exclude one of the source or just use one more.
That's difficult. That's a difficult definition. It is only distilled. It had not gone through any distillation, but it does perform well. So I've tried it on like a computer. It works just fine. It works fine for like computing tasks and so forth. I'm not sure if that satisfies people's definition of it. I think. Yeah. So the way it works is it puts a thing like an XML tag, and then it does some, it does a lot of tokens there, and then once it's satisfied, it does a little click tag, and then it's
Any other questions before we stop?
You're talking about second subprint, like trying to build two heads.
yeah.
Is that something specific to English language? If you make a prompt in another language, then does the model behave?
It's a very interesting question. I'm not sure, and especially in the space of these reasoning models, because they're not conditioned on inputs, they also aren't conditioned on sticking to a particular language. So rock.
I was asking because you are saying some of are correct, subconscious. But it sounds like most of it is coming from distillation.
It could be. It could be. Yeah.
If you go to Spain or Turkey or China, the collective subconscious will be different, but others will not connect.
Yeah. I will stop the recording here. There's some hot takes that I can.
Okay, paid subscribers on YouTube video. You could have gotten this, but